Welcome students in Excellence Classes Way of Learning. Here we are going to discuss some concepts of chapter Real Number. Now the first concept is Euclid's Division Algorithm. Euclid's Division Algorithm and Euclid's Division Lemma. Euclid's Division Lemma. It is very important and conceptual concept of this chapter. Okay students, so first of all, to clear this concept of Euclid's division algorithm and Euclid division lemma, it is very important to know the difference between algorithm and lemma. So here, algorithm. So what is algorithm? An algorithm is a series. An algorithm is a series of well-defined steps. An algorithm is a series of well-defined steps. Listen carefully, students. An algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. An algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. ध्यान से समझिए स्टूडेंट्स, एल्गोरिथम एक वेल डिफाइंड स्टेप्स की सीरीज है जो किसी एक टाइप की प्रॉब्लम को सॉल्व करने का प्रोसीजर देती है. ओके, सो नाउ लेमा. व्हाट इज लेमा? इट इज प्रूवन स्टेटमेंट. इट इज प्रूवन स्टेटमेंट used for proving another statement. It is proven statement used for proving another statement. Okay? लेमा एक प्रूवन स्टेटमेंट है जिसका यूज अनदर स्टेटमेंट्स को प्रूव करने में किया जाता है. ओके स्टूडेंट्स, क्लियर? So now we are going to discuss Euclid's division algorithm. Euclid's division algorithm. Okay, so here Euclid's division algorithm is a technique to compute the highest common factor, means HCF, of two given numbers. So Euclid's division algorithm is a technique to compute the highest common factor. Highest common factor means HCF. Okay, highest common factor of two given numbers. Euclid's division algorithm is a technique to compute the highest common factor of two given numbers. So here, steps taken to find the HCF of two numbers are as under. So here, first step is identify the greater number of the two. Identify the greater number of the two. First of all, given numbers से greater number को identify करना है. Okay? Now second, consider the greater number. Consider the greater number as dividend. Consider the greater number as dividend and the smaller one as divisor. And the smaller one as divisor. Now third step is find the quotient. Find the quotient and the remainder. find the quotient and the remainder. Now fourth is, if the remainder is 0. If the remainder is 0, then the divisor is required HCF. If the remainder is 0, then the divisor is the required HCF. Okay? Otherwise, go to the next step. So, next step is, take the remainder as the new divisor. Take the remainder as the new divisor and the divisor as the new dividend. Take the remainder as the new divisor and the divisor as the new dividend. Okay, students? So now repeat this process till the remainder 0 is obtained. Till the remainder 0 is obtained. The last divisor for which the remainder is 0, the last divisor for which the remainder is 0 is the required HCF. Okay, students? Is the required HCF. Euclid's Division algorithm या ये कहें long division method या long division algorithm is based on Euclid's division lemma. Euclid's division algorithm is based on Euclid's division lemma. Okay, students? Listen carefully, students. This entire algorithm is written in a proven statement which is called Euclid's division lemma. Again, this entire algorithm is written in a proven statement which is called Euclid's division lemma. So now Euclid's division lemma. Okay. So if A and B be two given positive integers, if A and B be two given positive integers such that A greater than B, then there exist unique integers Q and R such that there exist unique integers Q and R such that A is equals to B into Q plus R. Okay, where R is greater than equals to 0 and less than B. Okay, it is known as Euclid's division lemma. It is known as Euclid's division lemma. Okay, students, if A and B be two given positive integers such that A greater than B, then there exist unique integers Q and R such that A is equals to B into Q plus R, where R is greater than equals to 0 and less than B. It is known as Euclid's division lemma. So now we goes to discuss some examples for clear this concept. Okay. Question number 1. Find the HCF of 135 and 225 by using Euclid's division lemma. Okay. Find the HCF of 135 and 225 by using Euclid's division lemma. Okay. So first choose the largest number, that is 225. Okay. All of you know that as per the Euclid's division lemma, A is equals to B into Q plus R. A is equals to B into Q plus R. Here A किसको represent कर रहा है? Dividend. Here A represents dividend and B represents divisor. And Q for quotient and R remainder. Okay students, ये ध्यान रखना है आपको. So here by using Euclid's division lemma, we have dividend 225 is equals to divisor 135 into quotient plus remainder. So to find the quotient and remainder, we have to use division method. So here 1, here 135, here we got 90. 1 is quotient and 90 is remainder. So here 1 and here 90. Okay. यहाँ तक clear है? Here remainder is not 0. Here remainder is not 0. So we take remainder 90 as the new divisor. So we take remainder 90 as the new divisor and the divisor 135 as the new dividend. ध्यान समझिए स्टूडेंट्स. Okay. हाँ. Here 135, here 1, here 90, here we got remainder 45, quotient 1 and remainder 45. Here dividend क्या होगा यहाँ? 135 is equals to divisor 90 into quotient 1 plus remainder 45. Okay. Here again remainder 45 is does not equals to 0. So again we apply Euclid's division lemma. So again we apply Euclid's division lemma. So here we have here 90, here 45 to the 90, here we got remainder 0. Okay. So here 90 is equals to divisor 45 into quotient 2 plus 0. here we got the remainder 0. Okay, here we got the remainder 0. Here we need to stop applying the Euclid's division lemma further. Okay, here we need to stop. We need to stop applying the Euclid's division lemma further. From observation of the last value, we can conclude that 45 is the highest common factor of two given numbers. Okay, students, listen carefully. From observation of the last value, we can conclude that 45 is the highest common factor of two given numbers 135 and 225. 45 is the required HCF of two given numbers. Okay students, clear? Again एक बार समझ लेते हैं. 225 divided by 135. Here dividend 225 and divisor is 135. So 225 is equals to 135 into quotient 1 plus remainder 90. Okay, so here remainder 90 is not equals to 0, so we take 135 as new dividend and 90 as new divisor. So here 135 is equals to 90 into 1 plus 45. So here again we apply Euclid's division lemma. So we have 90 is equals to 45. 90 is equals to 45 into quotient 2 plus remainder 0. So here we got the remainder 0. So required HCF is 45. Okay, clear? So now, for example, question number 2. Find the HCF of 78 and 980. Okay. So first choose the largest number. So here 980 is largest. So by using Euclid's division lemma, we have dividend 980 is equals to divisor 78 into quotient plus remainder. To find the quotient and remainder, we have to use division method. So here 1, 78, here 0, here 2, here 0, here 2, 156. So here we got remainder 44 and quotient 12. So here 12 and here 44. Here remainder is not 0. So again we apply Euclid's division lemma. Here remainder is not equals to 0. So again we apply Euclid's division lemma. So here we have new dividend 78. Okay, 78 is equals to new divisor 44 into quotient. So here quotient क्या आएगा? Here 1, here 44, here 4, here 3, 34. ये रिमाइंडर हुआ हमारा. यहाँ क्यूसेंट 1 प्लस रिमाइंडर 34. So here 34 is not equals to 0. 34 is not equals to 0. So again we apply Euclid's division lemma. again we apply Euclid's division lemma. So we have here 44, here 1, here 34, here 10. So 44 is equals to 34 into quotient 1 plus remainder 10. Here again 10 is not equals to 0. So again we apply Euclid division lemma. So here 34, here 34 is equals to 10 into quotient. क्यूसेंट क्या आएगा यहाँ 3 या 30 ये 4 रिमाइंडर है. सो क्यूसेंट 3 प्लस रिमाइंडर 4. Here again 4 does not equals to 0. So again we apply Euclid division lemma. So here 10 is equals to 4 into here 2, here 8, remainder 2. Here 10 is equals to 4 into quotient 2 plus remainder 2. Here again 2 is not equals to 0. So again we apply Euclid's division lemma here. So here 2 2s are 4. Here we got remainder 0. So here 4 is equals to 2 into 2 plus remainder 0. Here we got remainder 0. So here we need to stop applying the Euclid division lemma. From observation of the last value, we can conclude that 2 is the highest common factor of two given numbers. So here 2, the last divisor, here 2, the last divisor for which the remainder is 0 is the required HCF. Okay students, so here HCF, highest common factor of 78 and 980 is 2. Now here we discuss the last example for clear this concept. So here find the HCF of the positive integers find the HCF of the positive integers 180, 252 and 324 with the help of Euclid's division algorithm. Find the HCF of positive integers 180, 252 and 324 with the help of the Euclid's division algorithm. Okay. Here 180, 252 and 324 are three numbers. So first we apply Euclid's division algorithm on 180 and 252. So by using Euclid's division algorithm on 180 and 252, we have here 252 is the larger number in 180 and 252. So 252 is equals to divisor 180 into quotient plus remainder. To find the quotient and remainder, we have to use division method. So here 1, here 180, here 72. Here we got quotient 1 and remainder 72. Here 72 is does not equals to 0, so we take 180 as new dividend and 72 as new divisor. So here 2, here 144, here we got remainder 36. So here 180 is equals to, by using Euclid's division algorithm, 180 is equals to 72 into quotient 2 plus remainder 36. So 36 is not equals to 0. So again we apply Euclid division algorithm. So here 72, here we got remainder 0. So here 72 is equals to 36 into quotient 2 plus 0. Here we got remainder 0. So HCF of 180 and 72 is 36. Okay. So here HCF of 180 and 72 is 36. So now using Euclid's division algorithm, on third number 324 and the HCF of two numbers, that is 36. Here using Euclid's division algorithm on third number 324 and HCF of two numbers, that is 36. So here we have dividend 324. Here 324 is equals to divisor 36 into quotient plus remainder. So here 324 divided by 36, 36 nines are 324. So here we got remainder 0. Here 324 is equals to 36 into quotient 9 plus remainder 0. So here 36 is the required HCF. Okay. So here HCF of 180 to 52 and 324 is 36. Okay students, clear? Again एक बार समझिए. We have to find the HCF of 180 to 52 and 324. So first we find the HCF of 180 and 252 by using Euclid's division algorithm. So here 252 is equals to 180 into quotient 1 plus remainder 72. Here 72 is does not equals to 0. So again we apply Euclid's division algorithm. So here 180 is equals to 72 into 2 plus 36. Here 36 is does not equals to 0. So here 72 is equals to 36 into 2 plus remainder 0. Okay. So now HCF of 180 and 252 is 36. So now using Euclid's division algorithm on third number 224 and HCF of two numbers, that is 36. So we have 324 is equals to 36 into 9 plus remainder 0. So the required HCF of 180, 252 and 324 is 36. Okay students, in next class we will discuss exercise 1.1. Okay students, keep learning, keep practicing.